Now that we are reading from our TCP stream, let's see how we can handle the result. So as we can see, the read actually returns a result. The reason for this is that the read might fail. Our first job would be to actually match on this result. We already know how to do that. And we'll have two cases. We'll have our OK. And let's see what does the result return. It returns some number. So it will pull some bytes from the source into the specified buffer that we provide. And it will return how many bytes were read. Okay, so for now we can just ignore that number and leave it like that, and it might fail. So if it fails, it will wrap an error, and we would like to print that error. So we can say print line, and we actually failed to read from connection, and we want to print our error message. For the body of our OK case, let's start by logging the request that we receive. So we would want to print received a request. And here we want to print our request. But now we have a problem. We just have some buffer that contains numbers. This is not text. This would not be readable. So we have to convert our buffer into actual text so we can print it to the screen and debug it if we need to. Conveniently, the string struct has an associated function called from UTF-8. So the from UTF-8 function expects a parameter that would be some buffer with bytes, and these bytes have to be valid UTF-8. We see that this returns a result, and the reason is that it might contain an invalid UTF-8 bytes, and then the whole operation will fail. But in our case, we don't really care if the request is valid or invalid UTF-8. This will be handled later when we validate the request. Now, we just want to log it to the screen. Conveniently, the string struct has another function called from UTF-8 lossy. And this one does pretty much the same thing. You give it some buffer with bytes, but this function will never fail. It will convert a slice of bytes into a string, including the invalid characters. The thing that it will do is, every time it sees some invalid UTF bytes in the body, it will substitute that with this symbol here. This is exactly what we want, a function that cannot fail, and it will always successfully log the message that we received. So we pass a reference to our buffer. All right, now we have some functionality to log the incoming requests on our server. Let's go to the console. First, let's check if everything compiles. And yeah, we see that everything builds just fine. Now we can actually run our server. If we run it, we see that it logs the address it's listening on, but the process does not exit. The reason for this is that, as we remember, we have our infinite loop here. So actually, right now, our server is waiting there and it expects new connections. To test if it will actually handle a new connection, we can open another terminal and we can use netcat to send some data to the address of our server. So to do that, we can echo some data. Let's say we want to echo test. And we pipe that through netcat. And we just have to tell it the address, which is 127.0.0.1, and the port we want to send it to. And if we execute that, yep, we see that our server received the message test and it logged it to the screen. So this is very cool. Our server actually works. We have a working TCP socket. Let's also test what will happen if we try to send invalid UTF-8. So here we can append or prepend some invalid UTF character. For example, we can say the hex value FF. So that would be 255, and that's an invalid hex character, and if we send that, we see that, yep, our from UTF-8 function actually replaces the invalid character with this special character. This is super cool, but one last test that we can do is to actually open a new browser and send the requests to our server. So we see that this is the address of our server, and if we paste that here, bam, we see that our browser sends the bunch of requests to our server. So we can see that we received the request, and this is the first line of the HTTP request. So it was a GET request to the root of the page, and it was using the HTTP 1.1 protocol. And this is followed by all the headers, and then it has an empty body. And we see that Chrome will keep trying to ping our server because it's actually failing to return any data. A cool thing that we can do is we can also try to test some path, and we see that the new request actually has the /test path. This is amazing. We know that our code can successfully receive HTTP requests from a real browser, and what's left to do now is just parse that request and then decide what response to return.